In this lesson, we are going to learn how to do inverses and how to solve logarithmic equations using different properties. So yesterday we talked about graphing, and now we're going to kind of see how the exponential functions and logarithmic functions are inverses of each other. One thing to note is that this is similar to chapter 9 when we were finding inverses. All we're going to do to find an inverse is we're going to switch x and y. And then we're going to change between logarithmic and exponential form. So, for example 1, f of x equals 9 to the power of x. We're going to change out f of x first. We're going to do y equals 9 to the power x. Then we're going to switch x and y. So x equals 9y. Well, I don't want y to be an exponent. So in order to change this around, I need to switch to logarithmic form. So take the base 9, so log base 9 of the answer, x, equals the exponent, because a logarithm is an exponent. And finally, we just need to switch y equals out. So we need to go back to f inverse of x equals log base 9 of x. So now example 2. Same logic. Change g of x for y. So y equals log base 4 of x. Well, in order to change, we need to change x and y. So x equals log base 4 of y. Well, to isolate y, I need to change this into exponential form. So remember, the base is the exponent of the answer. So the base 4 raised to the exponent is y. And again, change it out. G inverse of x equals 4 to the power x. So again, we can use changing between forms to solve logarithmic equations as well. So here are some examples. If I want to solve this equation, well, I need to rewrite it. 3 to the negative second power is x. Well, 3 negative power, we know that makes it a reciprocal, so we're going to take 1 over 3 and square it. And if we square 1/3, we get 1/9 equals x. So now let's change log base x of 27 equals negative 1/3. Take the base to the exponent equals the answer. X to the negative third equals 27. Well, to solve this, you have to do a little bit of thinking. Well, negative 3, that means I can reciprocal this and make it positive. So I can take x to the third equals 1 over 27. To get the third away, I know I need to take the cube root of both sides. Well, the cube root of 1 is just 1. The cube root of 27 ends up being 3. So I've got x equals 1/3. Now recall, if a base isn't written, we know that that base is the natural base, is the common base 10. Remember when we had two exponents that were equal to each other? We could set the exponents by the power, by the 1-to-1 property. Well, same thing with bases. If you have two logs equal to each other of the same base, the 1-to-1 property lets us go ahead and take what they're equal to and get rid of the logarithm. So x squared equals 16. Now I can solve this problem. I can take the square root of both sides. I get x equals plus or minus 4. Now in this case, we can have both these answers. You always have to check though. If I put positive 4 in here, I end up getting 16. If I put negative 4 in here, I still get 16. But if this was not x squared, if it was just x, I could not use negative 4 as an answer because I cannot have a negative log. Now recall for a second those application problems we had that were compound continuously. So remember the formula A equals P e to the RT. Now we're going to use the natural log. So now we can use ln, the natural log, to solve for the rate or time. And we can do that because we have those properties that let us bring powers down. So let's walk through an example here. How long does it take for $100 to grow to $250 at 12% annual percentage rate compound continuously? Well, my principal amount is 100. It grew to 250. That is the new amount. 12%, well, that's the rate, but remember the rate always has to be a decimal. And it's asking how long, so I want to know what t is. Compound continuously tells me I'm using Pe raised to the RT. So A equals Pe raised to the RT. Put in our substitute here, we get 250 equals 100 e 0.12 t. Well, in order to take the natural log of both sides, I need to isolate e, because then I can use the property. So divide by 100 first. 250 over 100 is going to reduce to 5 halves equals e 0.1212 t. So again, remember that the natural log of e is just 1. That was our property that we had in the last lesson. So if I take the natural log of both sides, well, the natural log and e go away. So now I have the natural log of 5 halves equals, well, the power is coming down, so it's 0.12 t. To solve, all I have to do is divide both sides by 0.12. So let's go through that in our calculator. Go ahead, natural log is down here under log. So I want the natural log of 5 halves, 5 divided by 2, and I'm going to divide that natural log by 0.12. I get 7.64, rounding to 2 decimal places. So t equals 7.64, and I'm talking about years here. So now I want you to try the following problems from your book on your own. This is actually going to be part of the in-class assignment tomorrow, so you'll get a head start on that.